Hello, my name is Hailey, and this is Lab 3, Magnetic Field of a Bar Magnet. So, in this lab, we're trying to figure out the behavior of the magnetic field produced by a small bar magnet, and we're doing this using Biot-Savart's law, and we're measuring the magnetic field with a smartphone magnetometer app. And some of the fundamentals in this lab was using Biot-Savart's law and distance dependence to see how much field was produced on the dipole magnet and the relationship between these values. Um, so the fundamentals that we use are a magnetic dipole, which behaves like a north and south pole, and then we also use Biot-Savart's law, which helps predict the magnetic field along an axis. And the last one we use is distance dependence, which is derived in this equation, where k is a constant and n is a power, to show how the field gets weaker with distance. And the results we got were the magnetic moment was 2.125 amps per meter squared. So the system in this experiment was a bar magnet, and the surroundings were everything else. And here are some of the details on how the experiment was conducted, with the initial conditions being that the magnet was east to west and the phone was north to south. And we measured on axis and at a 45-degree angle. Some of the observations that I found when doing this experiment was that the magnetometer, when it was far away from the magnet, it has almost a zero magnetic field, and this is because the magnetic field is going to start to weaken and approach zero. And also, when the magnetometer gets closer to the magnet, the x component is going to increase, and this is because the magnetic field becomes stronger. And some of the calculations that we had, so on our Excel, this was the equation we got, where -3 was the slope, or n, and -14 was ln of k, and then k ended up being 4.25 times 10 to the power of -7. And using all these values, we plugged it into Biot-Savart's law and set it equal to distance dependence, and that's where we get the mu, which is equal to 2.125 amps per meter squared. And these are the results of the experiment that I put in the Excel table. The top one is measuring when it was off the axis by 45 degrees, and the bottom right is when it was on the axis. And here is the graph of ln bx versus ln r, where you can see a negative relationship between the two values, and these are the values that we use to calculate the magnetic moment. Okay, so for GlowScript, here's my function for calculating a dipole, and here are the 6 vectors of the observation locations. And next, I drew the axes, so the on-axis and off-axis, and also I drew the more observation points here. And here, these are the lines that represent the results of the experiment. And this is the result of the GlowScript code, where it has all the values of the axes and the observation points. So some errors that we might have ran into were that the Earth's magnetic field might have affected the values that we measured. And also another potential error is that the smartphone might not be accurate because it depends what app you're using, and it may vary between different apps. And finally, the last error that might have occurred is that I might have had the wrong positioning for some of the calculations, which would have messed up the values. And finally, some questions to answer is that what if I had not orientated my experiment to compensate for the magnetic North Pole and instead laid out my meter stick at another angle? And if I did this, my results would have been different because of superposition, and the Earth's magnetic field would have affected the bar magnet. And if I stuck 2 magnets together and I ran the experiment again, that would change my experiment because it would increase the range of the magnetic effects, but distance dependence would still be the same, just the values would be a little larger.